Kia ora tātou. In this video we'll look at strong and weak bases, whereas in the last video we looked at strong and weak acids. So some strong bases, and there's fewer examples that I can think of for these, but basically we've got sodium hydroxide, or that is lye, which is a white powdery substance, and then we could just take any group 1 metal and put that with hydroxide, and that will give us a strong base. So it could be lithium hydroxide or potassium hydroxide. We've also got, weak bases could be ammonia or any amine. So we would have kind of looked into this for organic chemistry, and then any sort of group 2 or group 3 metal plus hydroxide, we won't look into that, but basically they're less soluble, so they won't fully dissociate. So you could consider them to be weak bases as well. So an example of that would be magnesium hydroxide. For the strong and weak bases for this course, we're really just going to be looking at strong bases, namely sodium hydroxide and ammonia. So let's have a look at how they form strongly basic solutions or weakly basic solutions. So we could have sodium hydroxide, which by itself, when there's no water involved, is a solid. And if we react that with water, it will dissolve, and the sodium ions will go into the solution, and the hydroxide ions will go into the solution as well. So it just completely dissociates, and it's the presence of the OH minus that makes this a strongly basic solution. So probably a better way of writing this actually is, because water is not really involved in the reaction, is that we would just draw an arrow and have H2O on the top. So slightly different to strong bases that actually react with the water. This is just the base dissociating fully in the solution, and then it's because of these hydroxide ions in the solution that the solution becomes strongly basic. Slightly different with ammonia. Ammonia does react with water to form those hydroxide ions. So when you look at ammonia like this, there's no OH as part of that. So how do we get from ammonia to forming a basic solution? So to have a basic solution, you need to have hydroxide ions in the solution. So we could react that with water, and what happens is that instead of like an acid, instead of this giving a hydrogen to water, it actually acts as a base by accepting a hydrogen ion from the water. And so what that does is that it leaves an OH minus in the solution, because we've lost one hydrogen from water, so now we're left with OH minus, and we get NH4 plus. This NH4 plus is called ammonium. And yeah, I've said this a couple of times, but this is called ammonia. So weak bases are different because they don't necessarily, or except for that magnesium hydroxide that we were looking at, they can accept a hydrogen from water, which increases the concentration of hydroxide in the solution, which means that it's going to be a basic solution. So because this is a equilibrium reaction, just like with acids, we're going to have an equilibrium constant, which would be, for this case, it's another very low number. So that shows that very few of these particles will actually react with the water to form this, so it's not going to end up with a highly acidic, highly basic solution. And instead of it being Kc or Ka, it's Kb for the base dissociation constant. And that's all we need to know about strong bases and weak bases. In the next video we will look at conjugate acids and bases, and we will look at amphiprotic substances. See you then.